First lesson we're going to look at is graphing some linear functions. Now, what is a linear function? Well, it's an equation between two variables, and those variables today are going to be x and y. Those are the kind I generally use throughout the course, even on story problems. That gives a straight line on a graph. It's a relationship between two variables that when we plot that relationship on a graph, it's a straight line. Now, a linear equation, when there's x and y, takes place in two forms. There's 4x plus 5y equals 20. That's just an example. That is an example of a linear equation in standard form. And as you can see, the x and the y are on the same side. Variables x and y are on the same side of the equation. That's a simple way to explain it. Here's the equals, here's x and y. That's in standard form. Now right here, the variables are on different sides of the equation, and the y is by itself. So if they're on different sides of the equation and the y is by itself, it's what we call slope-intercept form. And you're going to need to know that. If you took Algebra 1 last year, we didn't work on that hardly at all. You're going to need to know that this year. So if you got the y and the x on opposite sides, it's going to be slope-intercept form, as long as the y is by itself. No multiplier in front of it, no coefficient there. Okay, that's called slope-intercept form. So, now that we know the two types of forms, we're going to go graph these. Graph the equation y equals 3x minus 5. Okay, and what I'm actually going to do here is first write down which form it's in. What's in standard form? No, it's not in standard because the y and the x are on different sides of the equals right here. Okay, so that would make it in slope-intercept form. So I'm going to write what form it's in, slope, and you need to do that, please, slope-intercept form. And now let's look at how we're going to graph this. Now, the best thing for you to do is put an M on your label. Label the coefficient in front of the X. That's your M. That's your slope right there. Okay. And then the other coefficient, or the other number that does not have a variable connected to it, it's just a constant term. That's your B. And that's always going to be like that. Now, after that, you're going to write the word slope, y-intercept. So slope and y-intercept. And it's real simple. The slope is going to be our m, which is 3. And the y-intercept is going to be our b, which is negative 5. Okay, pretty easy. Okay, now here's what I like to do. Remember, this is the x, this is the y right here. On the y, you're going to graph the y in the beginning, okay? In this case, the y-intercept's negative 5 right here, so we're going to be going just down 5 units. So 1, 2, 3, 4, 5. Okay, and then what we do is we use the slope from the beginning. Now, we always want our slope to be a fraction, and if it is not a fraction, if it's an integer, and 3 is an integer, you can make it into a fraction, but any integer can be made into a fraction by putting a 1 under it. Okay? And what we do, its slope is rise over run, so from the beginning point, we're going to go up 3 and 1 to the right, and we're going to do that. Usually I do it about 2 times, okay? So I'm going to go up 3 and right 1. So 1, 2, 3, right 1. And then again, 1, 2, 3, right 1. Okay? And then use your ruler to make the line straight. And what I usually like to do is I like to just write the original equation on it. So y equals 3x minus 5. You don't have to write that, it's fine. But what that does, that tells me all points on this line satisfy this equation, okay? Because let's look at this point right here, 2, 1. So at this point, x is 2, y is 1. Well, 3 times 2 is 6, and 6 minus 5 is 1. That's why y is equal to 1 at that point. And it goes like this, too. I mean, that's 1, negative 2, and you don't need to do all this. I'm just explaining why. I just need to see the line. If I take 3 times 1, that's 3. And if I take away 5 from 3, that's going to be negative 2. And that's why that line, every point on that line, a similar situation happens. Okay? All right, let's go to the next problem. Okay, let's write the form it's in. Y and X are both in this equation. Well, again, the y and the x are on opposite sides of the equation right here. So if the y and the x are on opposite sides, and the y is all by itself, it's going to be another equation that is in slope-intercept form. Okay? Okay, and what you can do with that, again, what you need to do after that is label your M and B. So M, B. And then simply write down the word slope y-intercept. Remember, the slope is always the m, so it's going to be negative 1/4. We already have a fraction here. It's not an integer, so we don't need to, like on the last example, we had to put a 1 under that 3, okay? Because that had to be a fraction. Well, here it already is a fraction, so we won't be needing that to do anything like that. And then the y-intercept is going to be positive 6. I'll put a little positive there so we know that. That easy. Graph your y-intercept first. Remember, this is the y line. You just go straight up or down. So we'd go up that time because it's 6. So 1, 2, 3, 4, 5, 6. And then we use our slope from the beginning, if we're going to go from this point here. But this time our slope is a negative. The top number is negative. So instead of moving up, we're going to be moving down. Okay? But I'm still going to be moving to the right. Okay? I always like to move to the right on my bottom. That's just me. But the top changes from sometimes it's up if it's positive, sometimes it's down if it's negative. Again, don't ever move left. I mean, the numerator number can be negative. In that case, you'll go down, and then you'll go up if it's positive. So what I'm going to do is I'm going to go down 1 and write 1, 2, 3, 4. And then I'm going to repeat that process again from this point. Down 1, 1, 2, 3, 4. Okay. As you can see, it's kind of easy because I don't even need a calculator to do it. Okay. Okay, and then this is just a repeat of this one. Okay, let's take a look at our next example. Y equals negative x plus 3. Actually, I'll do it down here because the staple's kind of in the way. So, what form is it in? Standard form or slope-intercept form? Well, it looks to me like it's in slope-intercept form because the y and the x are on opposite sides, and the y is by itself. So again, we have another equation that is in slope-intercept form here. Okay, so let's label the m, but where's the m? I mean, you don't have a number there in front of the x. Well, I can fix that problem if I put a 1 in front of it. And then that's going to be my m, and then the 3 is going to be my b. Okay, now I'm going to write the word slope and y-intercept. Okay, so the slope again is the number that's the m. That's going to be negative 1. It says it right on the paper. M, B, and m's a slope, b is a y-intercept. And positive 3. Now remember, we always need our slope to be in a ratio form. And if it's an integer, we convert it into a ratio simply by placing a 1 underneath it. Okay, so we go from the beginning. We go up 3. So 1, 2, 3. And then we use our slope to make points from the beginning. Okay, now, are we going up or down? Well, we'd be going down on this one because we have a negative. And then we're always moving to the right. I don't ever like to move to the left. Now, a lot of people make that mistake is they'll say, oh, it's negative, so instead of moving up, we move down, so instead of moving right, we must move left. No, it doesn't work that way, okay? Because I'm putting a positive 1 underneath there, and that's to the right. Your denominator is always going to be positive, generally, when graphing these. So, from the beginning, I go down 1, right 1, down 1, right 1. Okay. And again, I kind of like to write the equation y equals negative 1x plus 3. And that's just me. You don't need to write that, but that just shows me that that's the equation of the y. All right, now to my next problem. 2x minus 3y equals 9. Okay. This time, what form? Is it in standard form or is it in slope-intercept form? Well, look at your variables. This time the x and the y are on the same side of the equation. Okay, they're not on different sides. So this is in standard form. Okay, when it's in standard form, what I like to do is find the y-intercept and the x-intercept, and there's only going to be 2 points, and then I'll have the 2 points, because any 2 points make a line, and then I can just graph those. Now, the procedure for it is much different than slope-intercept, and you are going to have to maybe do some calculations here, and you might need a calculator if you want for some of it. Okay, first off, I like to set up a table. Instead of writing the word slope y-intercept in the MB, I like to just make a simple XY table. And what I do is I'm going to put 0 in for x, and at the other point I'm going to put 0 in for y. And what this is called, this is my y-intercept, and this is my x-intercept. Remember, this is x, and this is y, if you forget. Okay, now the procedure is pretty simple. You're going to write the equation twice. Copy it down twice. So 2x minus 3y equals 9, and 2x minus 3y equals 9. Okay, now let's find this y, what number goes here for y. Now, I know that x is 0. Okay, so I'm actually going to cross out the variable that is 0 because, look, if x is 0, then 2 times 0 is 0. And we can go ahead and eliminate 2x. Okay? So negative 3 times y equals 9. Remember, when the numbers, there's no sign between the number and the variable, that means times. And what's the opposite of times? Well, it's division. To find the missing piece of the puzzle, we would divide. Those cancel, and divide the other side by negative 3. So 9 divided by negative 3 equals negative 3. So you can go ahead and put negative 3 there. Just divide. Okay, now to find the x-intercept, well, we just do the same thing, but this time the y is 0, so we can eliminate the y term, because having a 0 there, 3 will be out too, because 3 times 0 makes the product 0. And we can eliminate that. Okay, so 2x equals 9. Remember, that means 2 times a number x equals 9. Do the opposite of times, which is divide. And I like to underline. That cancels, leaving me with just the factor of x, and I divide the other side by 2. And 9 divided by 2 is 4.5. Okay, now you just graph them and you pretty much have your line. Okay, so x is 0, y is negative 3. So, if x is 0, we're not going to move sideways at all, but we are going to go down 3. 1, 2, 3. And that's 0, negative 3 if you want to label the point. And then 4.5, 0. Well, what that means is I'm going to go on the x-axis, I'm going to go to 4.5, so the x is sideways, so 1, 2, 3, 4, and then half. And then the y stay in the middle, okay? And that is 4.5, 0. And we can go ahead and connect those. And if you want to write the original equation, that's fine. So 2x minus 3y equals 9. Okay, and that's just a repeat. Okay, next problem, I'm going to cross this out because the stapler's in the way. 4x minus 6y equals 24. So what form? You need to write the form it's in first so you know exactly how you're going to graph it. Well, it's looking like the x and the y are on the same side. Okay, so that would make that standard form. Okay, and again, standard form, the technique would be to set up our xy table. X is 0. and y is 0, and then we're going to write the equation out twice, and that's going to allow us to find the y and x intercepts. So 4x minus 6y equals 24, and 4x minus 6y equals 24. Okay, so if I know x is 0, we can eliminate 4 times x, because that would just be 0. So I'm left with negative 6 times y equals 24. Okay, so I'm going to divide both sides by negative 6, and those two factors cancel, leaving me with just the factor of y, and divide the other side by negative 6. And 24 divided by negative 6 equals negative 4. Okay, now if y is 0, we can go ahead and get rid of the 6y, because 6 times y is 0. And I can divide both sides by 4. And then divide, and 24 divided by 4 is 6. Okay. Alright, so let's graph 0, negative 4. So this is the x, this is the y. So if x is 0, we stay in the middle, and then we go down 4. 1, 2, 3, 4. And if x is 6, y is 0, so we're going to move 6 to the right. 1, 2, 3, 4, 5, 6, and then stay right there. And we have our equation. Remember, this is how I got 0, negative. You don't need to put these points on here, that's fine. And then 6, 0. Okay, and if you want, again, like I like to just write the equation down here, because all points, again, make this equal to 24. Okay. Now, you're going to wonder, again, we'll cross this one out, what is going on with this next one? 1/5 x plus 3/5 y equals negative 6 over 5. Okay, well, the x and the y, here's the equation, and the x and the y are on the same side, so that's going to be in standard form. But here's the problem that you kind of see. The fact that we have coefficients as fractions here. If coefficient is the number multiplied by the letter, so 1/5 is the coefficient there, 3/5 is the coefficient here. Well, what's nice is that they all have the same denominator. So what we can go ahead and do is get rid of this denominator, because we know we're going to do this, but I don't want to quite write this equation out just yet. I would like to get rid of this denominator here, okay? And the denominator is 5. And what you can go ahead and do is simply write dot 5, and those cancel. Dot 5, and those cancel. And now you got that. And then times 5, and those cancel. So now what do you have? I mean, you canceled the 5s. You multiplied all 3 terms by 5. So now you have 1x plus 3y, and then negative 6. Okay? And that's going to be the equation we're going to write down twice. It's really easy. Okay? You just times 5, get rid of it, times 5, get rid of it, times 5, get rid of it. So now we just proceed like normal. I write that down twice. 1x plus 3y equals negative 6. And again. Okay, so if x is 0, we can get rid of 1x, because 1 times 0 would just be 0. X and 1x mean the same thing, again. So 3 times y equals negative 6, so we undo the multiplication of 3 by dividing, and those cancel. And I divide here, and that's going to be negative 2. Okay, so that's my y-intercept, which I'll graph. And now if y is 0, we can go ahead and eliminate 3y, so 1 times 6 equals negative, 1 times x equals negative 6. Now, if it's a 1, you don't really have to divide. I mean, you can if you want, but you can really just eliminate the 1, because that's called the identity property of multiplication. 1 times any number equaling a number is going to be that number itself. Okay, so negative 6. Okay, so 0, negative 2, that's the x, that's y. So I'm going to stay, the x don't go anywhere, but the y you go down 2. And then you go back to the middle and just graph this point. You're going to go left 6, 1, 2, 3, 4, 5, 6, and then just stay. Okay, let's look at this next one. I'm going to cross out the top one because they're the same problem. Okay, x over 6 plus 5 over y, 5y over 6, or 5, 6y equals 4. Again, here's the equation. The x and y are on the same side. So, same. Or no, same. So if they're on the same side, they're in standard form. So standard. But again, and we want to make this table, but I don't really want to deal with the fractions when I have to do it this way. I mean, a fraction's fine if it's like in slope-intercept form, but usually in standard form, we want to get rid of those. So what's the denominator you have? Well, it looks like you have 6. So if I times 6 here, that'll cancel, and I'll have just x. If I times 6 here, that'll cancel, and I'll have 5y. I'll times 6 here, but that won't cancel. The 4 is actually going to have to be multiplied by 6, okay? Because there's no 6 in the denominator, so you don't get a cancellation there. But it's pretty easy. You have x plus, and I'm going to put a 1 in front of the x just so it's there, 5y, and then 4 times 6 is 24, okay? And then I just proceed with this equation here. I won't use the one with the fractions. 1x plus 5y equals 24. 1x plus 5y equals 24. Okay, so if x is 0, we can go ahead and eliminate 1x. So 5 times y is 24. Now, we are going to have to actually maybe punch it in on the calculator. And I don't have a calculator with me, but I know that it is 4.8, and that's okay. Okay, and then y is 0. We can go ahead and eliminate 5y. 1 times x is 24, so it's really just going to be 24. Okay, so let's graph 0, 4.8. So I'll stay in the middle of the x-axis, and I'll go up 4.8. So 1, 2, 3, 4, and then right here. Again, you don't have to make that. That's just telling you how I got there. 24, 0. Now, we're going to have to probably go by 5s here. Can make every unit worth 5 on the x-axis. So I'll count by 5s, 5, 10, 15, 20, and then 24 is just right there. So I'm going to put 24, 0 right there. Okay, and all I need to do is connect them. So, and I'm actually going to write this equation here without the fractions. Actually, you don't need to write the equation on the line. I just kind of have gotten in the habit of doing that over the years. Okay, now here's a couple of oddballs because you're like, well, how am I supposed to tell if it's in standard form or slope-intercept form if there's only one variable? Okay, x equals 2. Now let's look at this example that I have written down here. Now, x equals -4. That means x is always at -4. Y can be wherever. I don't even have y in the equation. So what I have done is I made an xy table. And x is always going to be -4, okay? So -4, -4, -4. But the y can be whatever, because it's not even in the equation. And the same goes if there's only a y with no x. Now let's say y equals 2. That means y is always at 2, and x can be wherever, okay? So I made an xy table. Y is equal to 2, so 2 under y everywhere. And then x can be wherever, because that's not even in the equation, okay? So we're going to make a table. And it's x that equals 2. Y is not even in here, okay? So x is always 2, regardless of y. Y has no bearing on x because y is not in the equation. Okay, so y is 1, 2, 3. And then we just graph each point. So 2, 1, that's the x, that's the y. 2, 2. And 2, 3. And what it's either going to be is it's going to be a straight either vertical line or horizontal line. Okay. All right, now here again, y equals -4. Again, it's not in standard form because you'd have to have the x and the y together. And it's not in slope-intercept form either. Okay. All right, so y equals -4. xy. Now again, here it's y. Y is always -4, and x can be whatever you want it to be. So I usually go with 1, 2, 3 because those are easy to graph. So 1, negative 4. That means in this function here, x always has to be equal to 2 on the line. In this function here, y always has to be equal to negative 4 on the line. And actually, to be honest with you, yeah. So 1, negative 4. 1, 1, 2, 3, 4. 2, negative 4, 2 down 4. And 3, negative 4, 3 down 4. All right. Again, if you want to write the equation on the line, that's fine. You don't need to. But I'm going to. Okay, and your assignment are these 6 right here. It shouldn't take you too long. Some of you sophomores, if you need to look back at how to do slope-intercept form or ask me, you might want to, because we did it a different way, but you need to know this way for this year. Okay. And that y and x are on different sides, so the y is by itself, so you want to use slope-intercept form here. That's your m, that's your b, slope, y-intercept, okay?